do have 3 kids, and my daughter, I have one daughter, when she was 3 years old, wanted to read in bed. And you guys probably know 3-year-olds don't really read, but they look at pictures and think they're reading. And she kept wanting me to leave her light bulb on. I would find, though, that a lot of times I was forgetting to turn the light bulb off, and I would go down there in the next morning or in the middle of the night, and the light was on bright, and I realized I had left it on. And usually when I left the light on, she would have a hard time sleeping through the night. So the aha moment was in the summer. I put Grace down to bed, and where her room is, so you just happen to not have curtains on the window, and the sun goes down late in the summer. And I noticed that her eyes just slowly adjusted, and then she fell asleep when the sun went down. It's like, that is awesome. I need that year round. And so that's what the drift light is. It's a light bulb that sunsets, basically slowly dims. And the best thing is Grace couldn't even tell that it was dimming because her eyes were adjusting to the light. Yeah? Are you sure? You can ask. Okay. And so,
where do you purchase this?
We sell these on, I think it's drift-light.com or C-Saffron, but I don't know. I think we probably usually sell them through Amazon. 2/3 of our business is on Amazon, so you guys probably use Amazon a lot. Apparently everybody else does too. So we had this idea, so we wanted a light bulb to sunset. Then taking that and turning that into a real product, as easy as that sounded, it was a challenge because, first of all, where do you start? We wanted it to be a regular bulb most of the time. Only sunset when you want it to sunset.
So, is there an insulator inside that slowly decreases the amount of wattage that goes towards the wire?
Sorry, what's that?
Is there an insulator inside that slowly decreases the amount of wattage that goes to the wire?
That's a good question. That is actually not how it works, but that is how you would dim a traditional light bulb.
How do you get the light bulb to start sunsetting?
That's what we're going to talk about. Because this was a problem where we had an idea of what we wanted to build. We had no idea where to start. So we had an electrical engineer in China, actually. We have a small team in China. And we just set the problem out to them.
How long did it take to build it?
From start to finish, about 18 months. Which is normal cycle. Like 1 year to 18 months before we product introduction. And so, we took this problem to actually the whole company, but it was an engineer in China came up with the idea that we did not want to have to connect this to a smartphone. It's cool to have a smart bulb connected to your smartphone, but there are a lot of problems with that as well. First of all, it's harder to build. Second of all, it's expensive. Third of all, it's prone to being hacked. You probably heard about a hack, the Russians hacking smart bulbs basically 2 years ago, and taking down popular websites by using people's smart bulbs, basically as bots. And so we didn't want to deal with all the security stuff, and he had a very simple solution, which was plug the bulb into a light socket, like a regular bulb, and that's all this is. Got pain. We can take it out later. All it is a regular light bulb, but you plug it in, and then when you turn the light switch on, it's regular light. But the question was, how do you start sunsetting? So if you turn the light on, turn it off, and then turn it on again, it'll give you a blink to let you know it's activated, and then it will dim until it shuts off, 37 minutes later. 37 minutes is not a magic number. We chose that because we looked at the average time it takes from the time the sun starts setting until it's set. But that varies a lot depending on where you are, and in some places, sometimes a year it never sets. So we just had to take an average, and 37 minutes was the average. And so we got the prototype. This guy was a genius, our engineer in China, and he found a factory that would make a prototype for us. And the prototype was so cheap, like I look back, because it was $500. I mean, for what we do, that is just insane. You know, most companies would quote 50 grand. But there was a company that really wanted to make it, and so they wanted to prototype it for cheap for us. So they made the prototype, shipped it over to us, and I tried it out for my daughter. And I realized they had made a mistake. It dimmed all the way down, but it never turned off. It stayed on the lowest setting, which is about 0.5%, as a really faint night light. And I was like, how could they mess this up? So I go to the Chinese factory and I'm getting mad at them, and I mean, not really mad, but kind of. I was telling them they made a mistake. And my daughter could hear me talking, and she came in the room and she was so worried. She was like, "Daddy, don't change it." She loved the nightlight. And so in that case, we actually took a mistake and we turned it into a feature. So now if you click the light switch 3 times, it goes into what we call moonlight mode. In moonlight mode, it dims, stays on as night. And it stays on as a night light as long as you leave it in that mode. To reset it, you have to turn the light off, leave it off for 3 seconds, then turn it on and back to normal. So, pretty simple idea, but you were talking a little bit about how light bulbs get dimmed. Can you say again how a normal light bulb is dimmed?
Once the insulator starts, you're decreasing the amount of voltage towards the wire.
Yeah, that's the key.
Dimmer and
That's the key. So with a traditional light bulb, you guys might not even know what traditional light bulbs are, but what me and Jeff would call a regular light bulb, before LEDs, incandescent light bulbs, they run at high voltages, and you reduce the voltage to make it dimmer, and you increase the voltage to make it brighter. Clear, right? You can't do that with an LED. With an LED, what happens when you increase the voltage? Anybody know?
it will die.
Yeah. Yeah, it doesn't usually explode. It could in theory, I guess, if you ran a high enough charge through it.
That'd be cool.
What would fail first is the driver. So the driver is switching from AC to DC. So you get AC out of your wall line, and it has to convert that to DC, so direct current voltage. And so the way that light bulbs dim is really cool. Has anybody ever heard the term PWM? PWM. So you're all going to learn something new today. That's good. You have a. Might know what PWM is? What is it? What does it stand for? You remember that? Pulse width modulation. And that sounds like a big word, but it's a simple concept. When you see an LED, are these LEDs, Jeff?
I don't know, actually.
What do they call you here, Mr. Lysette?
Yeah.
That's so strange, but I'll try. Okay, so Mr. Lysette, these are probably LEDs. It's unusual to not have LEDs. What happens is, when you reduce the brightness on an LED, you don't actually change the brightness at all. Can anybody think how that's possible?
Stop playing with your computers, folks.
This kid right here might have an idea. How can you reduce the brightness of an LED without changing the voltage?
Putting more voltage into it.
No, that's close.
Emmett, stop playing with your computer.
Reducing the voltage won't really change brightness because
Yep, they're on or off. They're different. It is either all on or all off.
it's not by heating up the wire and that's pretty light because it's hot.
No,
No,
that's
it's-
an incandescent.
That's
So what you do with an LED is you flick it on and off really, really, really fast. And so what I'm going to do is I'm going to leave this drift light with Mr. Lysette. And then you guys can try to come up with a formula for how you would dim a light bulb. And whoever does the best, he can just decide who tackles this the best. He'll get the light bulb too. But basically, in a second, we'll use 1,000 as a nice round number. We actually use a higher frequency, but 1,000 times a second, let's say. And 1,000, frequency of 1,000 isn't unheard of. 1,000 times a second, the light bulb turns on or off. And we get to choose. Maybe we turn it on every other time. Then it's 50% brightness. And it's just an optical illusion. It just tricks your eyes. Your eyes think that it's dim, but it's not. Just by changing what we call the duty cycle. So if it's on half the time, that means 50% duty cycle, 50% brightness. 10% duty cycle, 10% brightness. What we found is you start to get trouble when you get down to 1% duty cycle. And have any of you ever tried to dim an LED that's not supposed to be dimmed? You have? And what happens when you get down to the 5 to 10% range?
When it gets down to the 5% range, it'll start malfunctioning and it'll do things it's not supposed to do. Like sometimes it will dim a little bit, but
Yep.
it'll sometimes it'll get brighter and it just doesn't work like it's supposed to. It'll ruin the light itself. And
Yeah. The most common thing, and that is true, sometimes sometimes it will dim, but usually what happens, it flashes on and off.
Yeah.
And that's just a malfunction of, it means that it doesn't have a high enough resolution. So when you get down to below 10%. So we just had to account for that by ramping the frequency up, or how many times we switch per second.
Our eyes can only see 30 frames per second, so it'd have to be faster than that.
Yeah, it's always way faster than that. Even at 100 hertz, and hertz it means per second. At 100 hertz, you could detect a flicker. Some people, older people in general, who have worse eyesight, they couldn't even see a flicker at 10 hertz, but that's pretty unusual. You guys would probably be going into seniors. Do we have another question right here?
No.
Okay. So anyway, that is basically the problem was we wanted a self-dimming light bulb, and there were a lot of problems along the way, but this one ended up being a good product. We introduced it to the market, and the most important thing if you're going to design products is you're going to hate marketing because you're going to feel like, hey, they don't build stuff, they just go sell the stuff we're building. You got to learn to work with those guys. You got to learn to like them and work together, because it was really important for us that we had a strong marketing team introduce it that got us on all the top tech sites.
I had an idea for a light that automatically turned itself off.
Yeah.
So you know how like a breaker panel, when it goes out, the switch inside will flip up and
Yep.
so it turns off. I thought you know how metal expands when it gets hot. So if we made a light that took in more voltage, it could have something inside that say after an hour, the switch, if it got too hot, it would pop out of place, and then you could
Yeah.
reset when you needed to.
That would be one way to do it. There would be a lot of easier and probably more reliable ways to do it though, because the problem you have there is manufacturing tolerances, getting it perfectly so after 1 hour, for instance, it turns off would be a real engineering challenge. That would be next level stuff.
That's why it wasn't.
But it's possible. And anyway, what I want to encourage you guys to do is if you have an idea for a product, you don't need school. School's great, but you can't rely on your school to teach you how to do everything that you need to do. Go out there and research it. You have Wikipedia, you have more information than Thomas Edison, Nikola Tesla, any of these guys. You have at your fingertips more information than any of them had. You just need to channel your energy in the right direction. And I studied economics, I didn't even study engineering, and I've ended up doing engineering for my career. And so anyway, I just want to come in and share that with you guys, give you guys the challenge. Try to come up with a formula, and you don't have to be real programmers. This doesn't have to be code you can execute. The way we give code, we meaning as electrical engineers to our programming team, is we just make fake code shorthand, they turn it into real code. So we call that the schematic. The schematic being all the hardware components, and then we will write a quick schematic showing the software components as well.
If the timer inside happens to malfunction or be destroyed, would the light still function as a real light, or would it not work at all?
If the timer breaks, it wouldn't work at all.
Would it still be able to turn on and off, or is it kind of just...
Everything that's digital relies on crystal, and so if the crystals break, it's not going to work at all. It wouldn't even turn on. Now, if we changed the wiring and took out the CPU that's on board, because it basically just has a computer on it. If we took that out, we could make it work without the smarts. The way it is now, that fails, the whole thing fails.
So your central processing unit is what controls the timer?
Yeah, there's a real-time clock on board. It's actually all part of the same module, but there's a CPU and a real-time clock, an oscillator, crystal.
No, I don't think it's...
Does anybody else have any questions?
Tricking me with this.
What's the best thing you do in your job?
The best thing that I do? That's a great question. My favorite thing is probably flying to China and working directly with the factory on production. So I probably shouldn't do that as much as I do, but I truly love doing that, so I do.
How big is your company?
Not very big. We have 42 employees, and then we have 5 employees in China.
Can I touch your prototypes for you?
Yeah, sure. I'll give you prototypes, and I'll send them with Mr. Lysette. He'll give them to you, and you can put them through the ringer.
I want to do that.
I'll tell you right now, you could probably break our stuff pretty easy, but that would be good for me to know the failure